Welcome back to another episode, and in this one, we are looking at the M5 stack Cardputer or card computer. It's a micro PC or a microcomputer. It's based on the Stamp S32 module, which is an ESP32 based microcontroller breakout board, and it's a very well packaged microcomputer that you can put in your pocket. It's exactly the size of a visiting card, which also makes it exactly the size of a Raspberry Pi. So if you turn that around, yeah, fits perfectly on there. Let's go through the features, power it on, and then tear it down and see what's inside. So up front, we have a 1.4-inch IPS LCD display, microphone, your Stamp S32 module, a full QWERTY keyboard, which have very clicky buttons. Actually, they feel really well. So if I bring this closer to my mic, they are very nice and clicky. At the back, we have a full diagram of how the keyboard's layout, of what pins go to the inbuilt speaker, of the whole charging and power circuitry. We have two batteries inside. We'll take a look at those. The pinouts for the IPS LCD, it's 1.14 inch. I thought it was just 1.4 inch. And then you have the battery voltage sense pin, and then the port A, which ends up being this M5 stack header right there, which exposes G2 and G1 GPIOs. On this side, we just have the speaker, an SD card slot, a reset button up here, and an IR blaster, which you can use to send out IR codes for virtual remote and things like that. Also, it has magnet and its back plate, so I can stick it to things, and I mean, it is magnetic. And if you have like a metal plate or something, you can just place it there and it'll stay. So let's power it on, see what the default firmware is. I've had some concerns about the default firmware, which I don't like. Um, and then we'll tear it down and see what's inside. So let's power it on. And you can hear the chime when it powers on. And press enter. So the screen is bright enough, it's just not bright enough in the studio lighting. It feels a bit dimmer, but it's actually pretty good. The first one is the record app, which is interesting because it has inbuilt memory, and not memory as in SD card storage, because the SD card is absent from there. But it has inbuilt memory. It has 4 MB of RAM and some flash. But as far as I can tell, this is only writing to the RAM. So it has 4 MB of RAM and it can store a fair bit of audio. So I've been recording, and then if I press play, so you can see it automatically recorded the last few seconds, which is cool enough. And the audio isn't too loud or too clear, but it works as a good demo. And then we press the button and on the top, and it brings us back to the home screen. There's a Wi-Fi scanner app, which just scans Wi-Fi. It doesn't allow you to connect to a particular access point, but it just scans it, and it'll just show you the Wi-Fi and the strength that's around there. Of course, I have to blur all of it, but it shows a lot of these APs that's around my place and their signal strength. Moving on, we have ESP chat or ESP now chat. It's supposed to be like if you have two computers, you can like chat with each other, type random stuff. But of course, there's no one replying from the other side right now. And then we have an IR blaster or an IR, sort of, you can basically just send individual codes. You just need to enter two hex code, and it'll just send it through the IR blaster up top. Just because of the way lighting is and the IR filter on these cameras, you can't really see the IR uh, picking up. But when you are in a darkened room, you can actually see through a camera. You can see the LEDs blink, and it is working. It's working fine. Moving on, you have REPL, which is read, interpret, execute, program loop, something like that. I don't remember the full form. Basically, it's like a command line interface to do a bunch of things. It can't do a whole lot of things. It has a very limited Python library. Even like import machine doesn't work. So if I go and do machine, just the module isn't found. So, and also this is not running MicroPython, it's running something called PikaPython, and I don't really know what PikaPython is, and I had a quick look, and it's like something like MicroPython, but someone made their own, so fine, whatever. Python for microcontrollers. um, they say it's smaller than MicroPython, but who's counting? And then moving out, we have set Wi-Fi. Now this is where you actually connect to Wi-Fi. What you do after connecting to Wi-Fi, I don't know, because there's no app on the default firmware that needs access to the network. So just go back there, and you have timer. Now you think a timer would be stopwatch, an actual timer, and then your clock, but it is just system clock. It has a 1 to 128 mAh battery that's not traditionally removable. It still doesn't have RTC on the software that they gave us. So every time I reset the timer just resets. So if I go and reset the board and then go back to timer, it resets, and it's basically system time. It's the same time that it's showing up there. So I'm not sure why this app was here. Keyboard is a very interesting app. You can basically use it as a Bluetooth enabled keyboard and connect to devices, or you can use it as a USB keyboard and connect this USB to another computer, and it'll act as a USB keyboard. So we can take a quick look at the Bluetooth keyboard. I can just from my phone. It already shows. I have to open up my Notes app without showing much of my phone. And then we can go to a Notes app, open up a new note, and then can start typing, and it works. So yeah, that's a good demo of a keyboard of the M5 of the card computer, not like some of the other apps were just weird. But yeah, so that's working fine. And I'll remove my phone, and you can go back, and that will disconnect the keyboard app and just bring you back to the home screen. And then you have a notepad which requires an SD card to be present. um, and I don't know if that message is visible because it's in a very dark red, not even like a bright red font. Just says the SD card mount failed, so who cares. We can go back, and then there's just a hello app, which is a hello world app, which fine, like hello Cardputer, but that's it. So M5 have their own UI building tool. I don't know, it's called UI something, but that's not what I'm interested in. I'll probably end up writing my own firmware for this, making it open source, and so folks can use and contribute. uh, yeah, that's where the fun is in these things. They don't run Linux, so you just sit down and write everything on your own. Let's power it off. Let's see what's inside. Yeah, one other thing is it has a quirk where you cannot charge it when it's off, because when it's off, the larger battery of the two batteries mentioned here is disconnected. So when you plug it to charge and it's powered on, it'll charge. It just won't say it's charging, but it will charge, right? You plug it in, shows nothing. But if you turn it off and plug that in, it'll turn on. And now it's running from the internal battery. So it just shows the charge status of internal battery, and I can plug this out and it resets again because it's off. So I turn it on, and now it shows the charge status of the external battery. So plug it in, it turns on, and I can basically then turn this on and plug it out, and now the charge status doesn't change. Yeah, it's not a well written firmware. Like when you plug it off and turn it on, it will run on the internal battery. So yeah, some quirks here and there, but that's where the fun is. So let's go ahead and take it apart, see what's inside, and see what makes it tick. They do helpfully send you a Allen key, so you can take it apart if you don't have a set of Allen keys, I guess. This might take a second. Right, so the backpack is loose and I can just wiggle it out. There you go. And we have these keys here, and that is your battery right there. Now, this is where my first complaint, and first and only major complaint with this thing is it uses these pogo pins to connect to these battery terminals, and the battery terminals are very helpfully um, labeled plus and minus by like having the copper exposed, so this works well. But my only complaint is these the pogo pins, especially for power, they end up building a lot of carbon over time, and they will eventually degrade and stop working reliably. So you either clean it out or you just have to stop using them. I've had watches that have contacts like these, and when you charge them over and over again, the copper layer from this side of the PCB actually starts to erode, and that causes issues in the long run. So if you're planning on using this device for a while, or having the backplate removed over and over again, um, it doesn't really help to have contacts like these. I would have rather had a plug on the back PCB and then the battery going through that. I know this is easier to disconnect like this, but that's what my um, experience says, is to not use these pogo pins. Either way, so you have the battery here. It's a 1400 mAh battery, 5.18 watt hours. You have some sponge here, and beneath or under the sponge you have the magnets, and which also give this a bit of a heft. And then you just have a blank PCB here, and then some strips to keep the blank PCB in place, and the pogo pins are here. So there's not much else in this PCB, so there's no point taking it apart. uh, I'm interested in these holes. I'm not sure if these are meant as mounting holes or they are just like there for design. If you can make something that mounts through them and then clip it back, I've not seen much documentation on there. That should be interesting as an add-on to the Cardputer. And so and then the back side of the PCB basically shows a wiring diagram of things in a very uh, comic or sketchy way. And sketchy as in as a sketch, not sketchy as in bad, but it still shows it like that. I'm a bit confused about how the, I mean, I'll look at the schematic, but at how the keyboard is laid out, because it says 8 rows and then what is it, 7 columns, but you can see here it's four. So either they are replicating here, so you have 1, 2, 3, 4, 5, 6, 7, and then you have all these 7 rows, and then they go beneath it, logically speaking, they go underneath it like that. And so then you have 7 by 8 in that fashion, which sort of works out like that. So I'll have to map that out. That's fine, that's part of the process. With the battery pack out, you can still turn it on. It'll still turn on, and it's now using that internal 120 milliamp hour battery. And you can see the battery status for the smaller battery in there. I think that might deplete fairly quickly. I'm not sure what sort of a battery that is. All right, we're back. Camera overheated. What, it's January, almost Feb, but it's too hot and the camera overheats. It's amazing the weather here these days. Anyway, um, let's tear it apart. I think that's where we were. Powering out, it did turn on from its internal battery, and that's working fine. So turn it off and just take out the screws on the top, and that should basically drop the entire board. We'll see how the stamp itself, how the S3 module detaches. I'm also very interested in seeing what the secondary battery looks like because I don't know if that's LiPo. All right, third time's the charm. Now the battery ran out. All right, not sure what's happening with this recording session, but we'll carry on. Unscrewed the top two screws, and I think what's holding us is actually the stamp itself. So, not entirely sure how that will get out of here. Don't want to brute force it. Um, don't see an obvious way of removing it. And there we go. So that removes it. I hope I didn't damage any pins. So as you can see, that is the PCB, but we'll take a deeper look at it in a second. That is the backside of the stamp. So you have your LCD right there, which sits here, and it's actually connected to the stamp, not to the main PCB, using a ribbon cable that goes all the way to the stamp. And that's the M5 stamp, and with very fine pitch, I think that's 2 mm, very fine pitch pins. I really thought they would use the castellated holes right there to actually friction fit the stamp onto the baseboard, but they are not using that. They are actually using the physical pins themselves. So we'll keep it there, and look at the baseboard. And baseboard is just the keyboard. You have your 7.4 series logic for decoding the keyboard matrix. You have your 120 mAh LiPo pack, which I now know to be a LiPo pack and not a super cap as I was hoping. You have your SD card slot right beneath that. I think all of the charging circuitry is under there. I don't want to pull out the LiPo as yet. The the microphone is right there. You have the reset button, the shoulder button, the button to turn on and off the board, um, the speaker, and then the base for uh, the M5 stamp itself. So that's about it. That's it. That's all there is to the whole M5 stamp. It's in three major pieces, these two and then this one, and it all screws in together. So very nice build quality in my opinion, especially for a product like this, which doesn't really have to be a nice build quality, but it is. um yeah, let's put it back and see how that goes. And we will also I kind of wanted to talk I had about what I'm planning to do. I had some idea to use Zephyr on it. Not sure how far I'll go with enabling Zephyr on this hardware, but I'm hoping to at least get enough of it running to sort of show off the hardware. And like there's a button is going to be hard to install. So Not sure how to go about installing that. That's these switches, they are the hardest part. If you tear down anything, these are the hardest part to get back. Not sure how, like, it's somehow done in assembly, in the assembly line, but this is just something I can't deal with right now. How is this supposed to, so it's supposed to fit on, I think, like this. It claws on here, and that what turns it on and off. But how am I supposed to keep it to stay? Let's see. Oh no, that's the other way around. So we keep this at an angle, push this through, and there we go. All right, not that bad. All right, so first I'll turn on the other side, and the M5 stamp just goes in like that. Now I hope everything's lining up on that end. That's in, and you can actually try and power it on and see if everything works. That works. It means the stamp is fitted in properly. Not too bad. Right, turn that off and then screw everything in place. Right, that all is in place, powered on, and there you go. Works. Um, that's about it for this video. Thank you so much for watching. I'll see you in the next one. Hopefully I can have a few more episodes on the Cardputer, get the firmware working, and show more functionalities and what you can actually do with them once you start writing custom firmware for this thing. Thank you so much, and I'll see you on the next one.